Everyone, I'm Sunanta from SNS College of Technology, Department of Mathematics. As the continuation of the lecture series in the topic Statistical Data Representation, in this video we are going to see frequency distribution, problem solving made simple. So master the art of organizing and interpreting data through frequency distribution, transform complex data sets into clear, actionable insights that drive better decision making and statistical understanding. So first let us see what is frequency distribution. A frequency distribution is a statistical tool that reveals patterns into your data by showing how often each value or a category appears in a data set. Think of it as your data fingerprint. It organizes raw, messy information into clean, interpretable tables or graphs. This fundamental concept transforms chaos into clarity, making it easier to spot trends, identify outliers, and draw meaningful conclusions from your observation. So let us see the type of frequencies as ungrouped frequency, grouped frequency, cumulative frequency, and relative frequency. So the first one is a discrete type in which the bits are counted as 0, 1, 2, 3, and second was a group. In this we can see the continuous data set with rangings between 10 to 19, 20 to 29, 30 to 39, etc. Next one is a cumulative frequency, shows running totals of frequency up to each class, helps answer questions like how many values are less than or equal to x percentiles. So the last one is relative distribution, so which expresses frequencies as fractions, decimals, or percentages of the total. So this makes it easy to compare different data sets or understand proportional relationships. Next is constructing a frequency distribution table, collect raw data. Next, determine grouping strategy. Third one is count frequency. Fourth one is the creating table. So gather your observations systematically. This could be test score from 100 students, customer satisfaction rating, or monthly sales figures. Next is decide whether to use individual values or class intervals. For large ranges, group data into 5 to 10 meaningful intervals. Choose boundaries that make sense of your analysis goals. Next is count frequencies. Systematically count how many data points falls into each category or interval. Use tally marks for accuracy, especially with large data sets. Double check your count, add up to the total. Next is creating table. Organize result in a clear table with categories, intervals in one column and their corresponding frequencies in another. Add total and consider including relative frequency. The next one is visualizing frequency distributions. The first one, it is bar graph, perfect for category data. Each bar graph a category with height showing frequency, great for comparing different groups like survey responses and product preferences. Next is histogram. Histogram, specialized bar graph for numerical data through grouped into intervals. Bar touch each other to show continuous nature of data, ideal for displaying test scores or measurement data. Next is frequency polygons. So line graph connecting midpoints of intervals. Excellent for comparing multiple distributions or showing trends over time in frequency data. Next is line plot. Display individual data points as marked on a number line. Best for small dataset where you want to show exact values. Next is problem solving. So hair color probability. Here let us consider the scenario. A class of 43 students has the following hair color distribution. So there are 50 students with brown color, 10 students with black, 16 with blonde, and 2 with red. So the question is, what is the probability that the randomly selected student has neither blonde nor a red hair? So first, identify relevant categories. So student with neither blonde nor red hair is brown plus black. Next, calculate the total. There are 16 blonde and 15 brown and 10 black, so which is 25. Find probability. 25 by 43, which is 58%. Next is cumulative frequency and quartile estimation. So understanding cumulative frequency. Cumulative frequency builds running total as you move through your data, creating powerful insights about distribution patterns and percentiles. Next is calculating mean and standard deviation from frequency data. Working with group data, when data is grouped into class intervals, use the midpoint of each interval as the representative value. The approximation method maintains statistical accuracy while simplifying calculation for large data sets. Next is mean calculation formula. So here the mean calculation formula is frequency into midpoint divided by total frequency. Next is measuring data spread. Variance and standard deviation quantify how much data point deviate from the mean. Higher value indicate more scattered data, while lower value suggest data clusters around the average. So example is, in a complaint analysis, the mean is approximately 6.62 complaint with a standard deviation 2.6, indicate moderate variability in complaint frequency across the sales team. Next is tips for effective problem solving. So first one is to identify data structure first. Second one is use systematic counting method. Third one is leverage visual analysis. Fourth one is master cumulative applications. Next is summaries and key takeaways. Data transformation: convert raw ungrouped data into meaningful interpretable frequency distribution that reveal hidden patterns and insights. Next is statistical mastery. Master table groups and calculations to unlock powerful problem solving capabilities across diverse analytical scenarios. Next is confidence building. Practice with real data builds expertise in interpreting statistics and making data driven decisions with confidence. Thank you.